action.
Hello, my dear students, and we're continuing our study of chemistry. And of course, chemistry is a study of matter and the changes it undergoes. And matter is anything that has mass and occupies space. And I've explained that most matter is, we talk about substances and pure substances, but many of the things, I would even say most of the things around us, are not pure substances, they're mixtures. And one thing we're going to look at, besides properties of mixtures, is how to separate the components in mixtures. So you might call a bowl of cereal a heterogeneous mixture, where you have milk and cereal mixed together. But let's just talk about the cereal itself. This total you might consider a homogeneous mixture. It's a mixture of many different ingredients. You can read those ingredients on the side of the box. And one of the ingredients in total is that it has 100% of a lot of vitamins and iron that are required in the human diet in just one serving. And the question is, iron? What is there iron doing in there, and what form does it take? So I'm going to take some of this total cereal, and I'm going to try to grind it up in my mortar and pestle. When you do your lab, we're going to perhaps practice weighing out a specific amount. But I'm going to take some of this and do my best to grind it up. And make a uniform and finely ground sample of my total cereal, and grind those flakes up. I have another experiment we're going to do with the flakes that I'll put in our next video, but I'm going to try and grind those flakes up, and I'm going to do one of two things with them. Okay? If you look over here, I have a magnetic stir plate. Inside this beaker of water, I've got a Teflon coated magnet. And underneath the platform is a motor with a magnet attached that's spinning around, and it causes the magnet to spin and stir. And in chemistry, we call this a magnetic stir plate. It stirs things for us so we don't have to. Sounds a little lazy, but if you have to stir for 10 minutes or 20 minutes, this allows you to do it safely and effectively without having to stir continuously, and you can leave your sample behind. So I'm going to take my finely ground cereal and I'm going to split it into two parts. Half of it I'm going to put into a Ziploc baggie, and half of you will be conducting the experiment one way and half of you can conduct it the other way. And the other half I'm going to put into the water here, and I'm going to turn my stir bar on and let that stir for 20 minutes. And I'm going to measure out 100 milliliters of water, from my water bottle of purified, distilled, deionized water, my glass bottle, and I'm going to get in the light so I can read my numbers better. I'm pouring it into a graduated cylinder, a 100 ml graduated cylinder. And I now have 100 milliliters of water. And I'm going to mix this in with the total. Should be milk, I know, but water is better suited to our purpose. I'm going to press out most of the air and close my bag. And this slurry, I'm going to mix and let set around a very strong neodymium magnet. Neodymium magnets are made with a magnetic metal called neodymium. It's element number 60 down here in the lanthanide series. And they are very, very powerful magnets. And so I'm going to put the magnet here. Actually, let me do it on the clear side. I'm going to put the magnet here and push my slurry back and forth, trying to leave the magnet in the same place and see what we can find. And what we will find is that, yes, Total does have 100% of a day's supply of iron, and it provides an important nutrient for humans. We need iron. We usually get iron in our diet from a variety of sources, from meats. Spinach is a good source of iron, some vegetables. After World War II, when they started scrapping all the aircraft and replacing cast iron skillets with aluminum cookware, all of a sudden people in the South started having anemia, which is iron poor blood, and various anemias. And so, in the old days, when you cooked in an iron skillet and you scraped the food up and you scraped a little bit of iron in it, people didn't have some of the iron deficiencies that they have now. Of course, you can just take Flintstones with iron. I'll demonstrate this later, but let me show you what happens to our stir bar in this solution. I need to get it turning again. Earlier, I did this experiment, and I don't know if we can zoom in. I'll also try and magnify it. I have a magnifying glass right over there. But I have a stir bar, and you can see the little iron filings attached to the magnetic stir bar that came out of the Total cereal. Okay, now this one's only been spinning for a few minutes, and I'm not sure we've had time to attract all the iron to the stir bar. I'm going to pull it out and look at it. If not, we'll leave it going, and we will catch you and show you the results in the next video. Goodbye now.